Well, hello there again, friends. Today is 4/25/2022, and today is the Odin Project vlog day 97. And I am 11% complete through JavaScript, and boy oh boy was today's module a beefy one. um, Today I went over the fourth module, factory functions and the module pattern. I did it over the course of a couple days, so yesterday was Sunday. Excuse me. Did quite a bit on Sunday, and then finished it up today. I am by no means. I probably will take a second pass at least at some of the material. There is a whole lot in here to go over. A whole lot to know, a whole lot to understand. Probably not memorize because we're going to be going over it as we go through projects, I'm sure, and coming across things. But definitely meaty. Not only is the text long, but the art. There's a lot of articles and other outside resources sprinkled in. So I highly encourage you to take your time and don't skip over any of it. So we'll do the knowledge check. I don't anticipate this video being super long. I'm not going to drag you through the nitty-gritty of this because obviously these internal, intermediate or intermediary modules that I do is just part of my vlog. It's something I do and I've always done with you guys just to chart my progress, even if I'm not working on a project like these modules. There's no project on this. There's not even any exercises. It's just a lot of reading. But I will point to this interesting part here. When it gets to the modules section, it says, for those who prefer video lessons, here's an excellent YouTube series on modular JS that covers most of the content in this guide, modular JavaScript. So I skipped that because that part because I had already read through all the articles. I do fully intend on going back and picking it up because the reason why I initially skipped it is I thought they were talking about that the video guides would basically go over the entire, article, everything, but they don't. I think when I read into it a little bit more, they don't do factory functions, so it's not really the whole kit and caboodle. So it's just about. I think it's just over. Yep, just over modular. So I would highly encourage you to go through these. Like I said, I haven't went through these yet. It's the only thing I didn't do. Maybe I'll save that for tomorrow. My brain's kind of full right now, so as far as today goes. But nevertheless, let's hit up the knowledge check. So describe common bugs you might run into using constructors. So that takes you out to this link out here, this blog, WordPress blog, and it's actually a really good read. It's something I don't remember entirely clear right now because I read it yesterday, but the whole article is basically just going over why they don't like JavaScript constructors, and because there's a lot of things. It talks about like how you can have scope problems. So then when you define something and you're trying to call it and it's not in the proper scope, you're getting issues. You have namespace issues if you're like, for example, trying to use the variable C too many times, and it's taking on, and especially if it's in the global space, it's taking on additional or different values when it shouldn't be, and you don't probably intend it to be, but you just introduce those bugs because you needed it, to do that one thing in that one time and that for that one function. Goes over that. Excuse me. Got some allergies going on, and my Tourette's is active. And then it talks about you can use C instance of the instance of I guess that would be in a class-like around constructor-like objects. The word gets away from me right now what they call that. I guess that might be a method. Anyway, they talk about the problems of using that, because some people use that instead of using new for constructor, as we've learned in previous modules. And then it gives here an example of more scoping problems, and how your prototyping can be confusing, because some that might have prototypes properties, others don't, based on where they're at in your function and how they're called. And then he goes into factory functions and conclusion. So I covered more than I wanted to on that, but this one isn't really a cut and dry answer. The article itself is just kind of the answers, kind of spattered throughout the article. Basically, they're saying constructor example were clearly introduced to give JavaScript the appearance of other popular class-based object-oriented languages, but as was discussed here, can be misleading, at worst actively interfere with the ability to engage with the core structure of the language. Constructors run contrary to the prototypical functional and object-based nature that which JavaScript draws its strength. I believe that by putting them aside and by recognizing them as artifacts of a time when JavaScript was trying to look like something other than itself, he's just concluding the argument that he believes that constructors came about because programmers were wanting JavaScript to be more object class oriented, and since it's not, they introduced prototype and constructors, and that's why he argues to use factory functions instead of using constructors, to keep it in that native feel. And it'll make more sense when you read the article. So the second one is write a factory method that returns an object. So here's a factory method that returns an object. So we define a constant variable called person factory, and it takes on arguments or parameters of name and age, and then the arrow function invokes the person factory as a function. And so inside of that we have a constant say hello that is invoked again with empty parentheses and a arrow function, so it becomes a function, counts out log hello, and the most important part is the return statement. So factory functions, they return the result of your what's going on inside the block. So when you do that, you're basically calling the function to return information from the function back out, and that's in definition factory function. They're similar to constructors, but instead of using new to create an object, factory functions simply set up and return the new object when you call it, just like we see here. So instead of saying constant Jeff equals new space person factory, we just call constant Jeff person factory Jeff27. Jeff27 gets inputted up here and runs through the block, and then it returns back name, age, and say hello, which is hello, because it runs this private function inside there. And that's essentially the answer to that. Excuse me, sorry to cough in your ear there. Explain how scope works in JavaScript. Bonus points if you can point out what ES6 changed. So this takes you out to this West Boss article, and this talks about the how the scope works. It's not really long. It's really good though. I like his explanations. They're very easy to understand. Basically, in a nutshell, this at the top, outside of a function, would be called a global scope, and then something like this inside of a function would be a local scope, meaning the variable width 100 is only available within the function set width, and it's not available outside. So you can't see it it can't be seen outside. Now other parent variables can, yeah, obviously you can call, I always get this backwards. Okay. Now we're to run it. Is that going to work? Of course it's going to work because this width is available inside the function. So it works because you're calling set width here, and so the variable's inside, but he's just seeing this example as if var width was above function. He did set width, you would get a undefined because the var width is outside of the function and it doesn't see it. It's not available to it. So error width is not defined. So here's another example. So if console.log width, so this example of trying to call and reach width from the global context when this is a local variable to set width, so it's not available globally. That's why you get an error not defined. And it goes through a bunch of other example variations of that. And then the other part about it is the ES6 portion of it. Question that says bonus points if you can point out what ES6 changed. The only things I remember from this article is in ES6 you are introduced with let and const instead of using var, and what that does is allows you to use blocked scope like this right here, like kind of like we've been doing basically, and how we learned in New Age with ES6. Block has everything to do with the curly brackets, so just overly simplified version is if whatever's inside your curly brackets is local, and anything outside of the curly brackets would be a global. You can have global variable, you can have a local variable, you can have a global function, a local function, and it's all dependent upon the curly bracket. Of course, there's exceptions to every rule. That's not a hard and fast rule, but that's just one of the things from the article. So we'll just keep moving here. Explain what closure is and how it impacts private functions and variables. So the concept of closure is the idea that functions retain their scope even if they're passed around and called outside of that scope. And they're talking about this this print string here up here. So the idea is so in this case print string has access to everything inside a factory function, even if it gets called outside of that function. And the reason why is because we kind of already went over it in a previous example, is that we're returning print string, which when you put it inside curly brackets like that, that makes it that tells the runtime engine that print string is not a variable, it's an object. So in this case, it's a function. So print string is right here. So it's returning print string, and this is an example of if you're calling print string here down globally, you're going to get an error because print string in itself is only privately available because it's inside of the curly brackets, which is inside factory function. If you do capitalized string, that's also going to give you an error because capitalized string is also a local function inside of the factory function. Sorry if I said variable for print string, because print string is actually assigned as a function. So both these functions are private in themselves. However, if you run it through factory function, it might give you a different story. But in this example, taco.capitalized string is an error because okay, so we have a constant variable taco here, factory function, and we're inserting taco. So we're calling factory function up here, but we want to call capitalized string, which again is when you're skipping factory function, you're going right into capital string. Capital string itself is a private function, so you're going to get an error. And taco.spring string, can't talk. Taco.print string, it does work because we can access it from the return statement. So when it comes through here, taco is going to be inputted into factory function, and we're getting a return statement of the function of print string, which is console.log, that does have access to capital string because it's inside of print string, if that makes sense. So it prints out whatever's in print string, and that would be taco in caps, and then that gets console logged, and the gets inputted to print string, and then that's how you get it on the screen. Clear as mud, I know. Yeah, so that's closure, and why it's important is because as you see with this exercise, it's important to know, helps you understand what is a private and what is a publicly available object, or attribute, or not attribute, product, object, or variable or string or whatever like that. So describe how private functions and variables are useful. We kind of already went over that in some of these examples. So in the context of factory functions, closures allow us to create private variables and functions. Private functions are functions that are used in the workings of our objects and are not intended to be used elsewhere in the program. In other words, even though our objects might only do one or two things, we are free to split our functions up as much as we want, and it allows for cleaner and easier to read code, and only export the functions that the rest of the program is going to use. So it also it increases security, and it increases efficiency in the runtime engine because it's not running extra code it doesn't need to. So that's essentially the nitty-gritty in that. Use inheritance in objects using the factory pattern. So here, basically showing this example here of how this works. So you got your factory here, returning say name. We already went over the factory. Here's another factory for nerd because we're returning some interior, variables that were private. That return statement makes them public. And so we have this example of, okay, say we called globally out here, we called Jeff.sayName. That will work because when we throw Jeff up here into name, we have a constant private here, sayName, but we're returning sayName, so when we turn it, it then turns from private to public, so it's publicly accessible globally. So if I say public and global, I'm interchanging those to be the same thing. So my name is Jeff, so that works. And Jeff.doSomethingNerdy also works, because when you call that globally, it's going to go up here, put Jeff in here. Okay, let's run that, and then we come down here for do something nerdy. Jeff's going to be, sorry about that. It won't run in I won't run in person. I'm running nerd because do something nerdy's in here, and it gets that because we have a constant Jeff equals to nerd Jeff. So we're going to be inserting Jeff in here, and there's some code missing here, but obviously there's going to be some prototyping going on here. But anyway, do something nerdy works because even though do something nerdy is initially private, when we're turning nerd we're turning out of nerd, we're doing something do something nerdy is part of the return statement. So that particular function is now public, and that's why that works. Explain the module pattern. So there's a whole lot of stuff to this. So essentially, the module pattern is similar to factory functions, but the main difference is you have two empty brackets down here, and the key to that is what this does is an immediate invocation of the function of the statements inside of that function. So basically what this does is it's going to immediately call a constant calculator, and because this is in here, it's going to immediately run these, define these, instantiate and run them, and then it's going to return add, subtract, multiply, and divide immediately. And that's what you're getting down here as your example when you call them. They're not, excuse me, they're there's not a need for any public or private institution with these. They're just immediately getting spit out. And the benefit is that you're making it a module, so that you can easily come back to it later, and it makes the code cleaner instead of defining these all individually and then doing calculations on them individually. You can create basically a module as it sounds, and it can be its own function called calculator, and it'll do all this at once in one swoop. And there's even better ways to do it than this, but you can call the the value inside of the calculator function, and it'll run that. So describe IIFE, what does it stand for? And it takes you out to this blog post. So this stands for immediately invoked function expression, and that's essentially what I just went over here. So you have your empty brackets here, which immediately runs, tells it to push that back as a function and do it immediately. So it's gonna do that. So it's a short little article, but just that's essentially what it is. And they pronounce it iffy. The concept itself simple. The pattern is called immediate invoked function expression. So basically, you have your function, you have your name of it, and you have your parentheses, and you have your curly brackets, what you're going to do in here, and you can assign functions and expressions from that as well. Something there. Sorry, I'm trying to breeze through this. This video went longer than I wanted it to. Briefly explain namespacing and how it's useful. Excuse me. Namespacing is the useful side effect of encapsulating the inner workings of our program into objects is called namespacing. It's a technique that's used to avoid name collisions in our programs. For example, it's easy to imagine a scenario where you could write multiple functions with the same name. I talked about this in the beginning. In our calculator example, so yada yada yada. Basically, they're just saying namespacing is good way to keep you from running the same variable and having different functions and different values attached to it at various points because you needed it available at that particular block of code. They use the example of the calculator here. This is the calculator talking about. But namespacing, so you have calculator.add, calculator.sub, calculator.multiply, but you can namespace that out. If all of them were nicely encapsulated inside of an object, which they aren't, but if they were, then we would have no trouble with adding, doing calculator.add, display controller.add, or operator stack.add, which we would create modules for each one of these, and just imagine that being in the code, and that's basically namespacing. And so that you don't have to worry about trying to have calculator a calculator call doing it a second time to display it in the DOM in this example, or in the stack of your division, or in a different area. It's different name, does a different thing, and it keeps you from producing and introducing your own bugs, basically. So yeah, went way over on this. I knew it was probably going to be. I always say it's going to be a short video in the beginning, and it never does. So I should have known better, but I think I did say it was going to be short. But anyway, if you're still stuck along with me into the ride to this point, I appreciate you, and I thank you for coming along with me today to the journey. Please like, share, and subscribe for more content, and let me know in the comments section what your understanding is of module pattern and factory functions, and what you think of it. So next time we'll be getting started in a new project, just rolling right through them. Now right on to the next one, and then I'll be going on a vacation next week, so I probably won't get to too much. I'll probably briefly get started with one section 1. We'll do a video together and get everything all set up. Maybe I'll do it live. It seems like that kind of works out well, and it's kind of a good way to get started. We'll see, and then we'll see how far I get with that before vacation, because I am going on a family vacation next week, and I will be out of the state and enjoying my time, and I'll not be doing any of this. So just taking a little bit of a break, well needed. So anyway, with all that said, until next time, see ya.